So our next session is ISS Commercialization, one of my favorite ones. We put something like this together last year, I think, and I fostered one like this off on IAC a year or two ago, or three. And Bobby Watkins is our moderator, and Bobby has been with NASA, I didn't believe it was, 32 years, long time, but he's had really an interesting set of jobs. He's been the Director of Legislative Liaison Division, but he's not a lawyer. I don't think he's a lawyer, but he's been in DC for a long time doing that. He's Director of NASA's Marshal's Office of Strategic Analysis and Communications, but he is not a marketing guy. He doesn't have a marketing degree. He was Chief of Staff at Johnson, and he doesn't have a personnel degree. He's done all these jobs he doesn't know anything about, kind of like him. And he was also the director at Marshall's Michoud Assembly facility, and he does have an engineering degree, so he had a job he knew how to do. But Bobby actually manages the best kept secret of Marshall. And it's not necessarily best kept because it should be kept a secret, but just because it is kept a secret. And that he manages all of Marshall's support to its deep involvement, and let's take the word support out, let's just say Marshall's deep involvement in ISS and in development of the exploration programs and the lunar complex that we're going to have in a few years. Bobby is the first director of the Human Exploration Development and Operations Office at the center here. And that center was, the office was formed in 2017 and oversees Marshall's human exploration themed space operations in and beyond low Earth orbit, including commercial space transportation, complementing NASA's Space Launch System, and supporting increased science in the International Space Station. So he's responsible for supporting all of the PIs, managing the POC, managing all the life support work that's done here, and in the future managing one of our components of the lunar complex. So Bobby?
Thank you, Alan. Thank you guys for being here today. Let me just kind of say a few words about Alan, and again, thank you for all what he does for AAS, and also Jim Way, and also Chris. I mean, let's give those guys a round of applause. They do a heck of a job pulling all this together. Did everyone get a chance to enjoy lunch? Everybody had a good lunch? All right, so I'm gonna true confessions. I had 2 desserts. Anybody try the pecan pie? I had the pecan pie, and it was ridiculously good, but I'm a chocolate lover as well. So I had 2 desserts. I am wired and ready to go, all right? Now, if I crash and burn, you guys make sure So remember Jody said, you look to your left, you look to your right. If you see somebody kind of nodding a little bit, just kind of nudge them a little bit and just kind of keep them engaged, all right? Yeah, we're gonna. Matter of fact, we can do a 7-inning stretch. We may do that. Hey, yeah. Hey guys, we got a very interesting panel discussion for you today. Just walking over with some of the panel members, I can probably have 2 guys just have a discussion by themselves, but we're gonna really make this more interactive. Start thinking about your questions or things you have from a commercialization perspective. I remember a while back when the administration first talked about retiring the International Space Station in 2025, and we were getting our thoughts together on what that meant from a Marshall perspective and a payload operations perspective. And someone mentioned, ISS, Bobby, is going out of business. And I said, no, ISS is not going out of business. What this means, this is our next logical step from the federal government to make sure our industry partners are fully engaged with commercialization. And when I say commercialization, one of the things that are key to me is one thing to have a vendor to come in and do just your day-to-day work, but true commercialization is setting up a process, an entity where they can also bring in profit with some of the capabilities that they bring to bear. So I think you're going to hear a very lively discussion this afternoon. And again, feel free. What I would do from a format perspective, I would introduce the speakers. They would go through their materials or their charts or their presentation with you, and then we're going to save time at the end. So just think about what questions you have, and feel free to get those questions on the table. And we got the right guys that are going to give you some great answers, okay? So again, good afternoon. Welcome to our panel discussion for commercialization of International Space Station. As many of you know, NASA has asked 13 companies, one including that is represented on the panel today, NanoRacks, to study how the International Space Station commercialization can happen and provide answers to questions like, how would business plans look? how viable would a habitation platform look? How can the federal government take a different approach or a different role when it comes to commercialization? We're hoping to get some insight on all these particular aspects of the study later on this year, and of course, we'll be working that through overall processes on the federal side of the house. In the meantime, again, we have a great panel of participants that's going to talk to us today about commercialization and some of the things they're doing from a commercialization perspective. Our first panelist is going to be Lee Jankowski. Lee is a Senior Director of Business Development for the Space Systems at Teledyne Braun here in town, here in Huntsville. Teledyne has designed, built, launched, and installed the multi-user systems for Earth sensing, or the MUSES platform on board the International Space Station. Earlier this month, the first hyperspectral images from DLR, images that were taken and sent back to Earth from the International Space Station. The imager was designed by DLR, but was the first payload hosted aboard the Teledyne platform. Lee is going to tell us more about that experience and some other things they're also doing from a Teledyne Braun perspective. Lee.
Okay, thank you, Bobby, and thank you, AES, for allowing us to be on the panel. I am Lee Jankowski. I'm with Teledyne Braun. We're across the street here from UAH. I'm actually a UH grad, 1984, so if we've got some students here, gets to the questions, try not to ask too many difficult ones to me. You can pass them on as a fellow alumni. Teledyne Braun, we are one of 70 of the Teledyne technology companies. We're the largest, based out of Thousand Oaks, California. What we've got here is a timeline of all the major programs that we've worked in space. If you see, we started in the early 50s. Von Braun brought us over from Atlanta, and we were a machine shop, brought us over, got us started. So we've been in every major program since the early 50s through Apollo and Skylab and ISS, and now we're doing payload operations and integration with Bobby for the space station. We're moving into SLS now. We're building the LVSA, the Launch Vehicle Stage Adapter. We're about ready to deliver that. We are also doing flight systems operations analysis for SLS. We're doing that as part of one of our task orders for our mission ops and integration contract. And now we're moving into gateway utilization too. So we're doing some ops concept for utilization for gateway also. So I didn't talk about several of the platforms. I think that Bobby kind of stole a little bit of thunder what we're doing, but that's good. We started MUSES in 2012. We had a cooperative agreement with NASA to build this nadir pointing platform with four locations on it. We did install MUSES last summer in June. It's been operating flawlessly since. We did install last month the DLR DESIS hyperspectral imager and started receiving imagery within 48 hours. So why did we invest? In my charts, I'm trying to address a little bit about why commercialization of ISS. So I'm wanting to talk a little bit about why and some of our barriers. And that's basically what these two charts will be. So the first one with MUSES, why did we invest? The infrastructure's there for the ISS. We know that. We've operated, I think, almost 3,000 payloads on our contract. So we're very familiar with the power, data, thermal, payload return capability. There was a growing Earth observation commercial market. There was for processing of data, storing of data, and T-Cloud, and we wanted to take advantage of that. We have a corporate legacy of doing remote sensing. One of our sister companies is Teledyne Imaging, and of course the ISS payload operations work that we're talking about. Our value proposition is that we can put an equivalent instrument on board for half the cost of a free-flying satellite. Risk and barriers. When we first started this endeavor in 2012, we were really attacking that market of the big buses and knew that this would be a lesser expensive value proposition. But about that time, we had small sats hit the market, and we had to redirect some of our some of our concepts of how to get payloads on board. And so we've looked at using maybe tech demos and putting multiple payloads in canisters. We've been working that scenario. We're also trying to get the contract to launch time that it's about 18 months right now. We want to get it down to less than 12 months. We're working that. Another barrier is just the market awareness of MUSES, and I think that's something that we all share. It's not a NASA responsibility. It's not a CASIS. It's industry too, and we're trying to work through that. CASIS is doing a remote sensing challenge right now with us. We hope to have an announcement. I think we've had down select for another instrument, and in March I think we're going to announce the winner of that competition. And we also have a couple of announcements that we're close to making right now that are very close to adding to fill in those 4 slots. So again, recommendations, improvements, again, it's just making the market aware of it. Get out there. We've got a panelist up in Virginia right now at an oceanographer type venue where he's on a panel taking questions from them, from PhDs, and seeing if there's other instruments and applicability there. All right, so this is one that draws the most attention whenever we talk to people around. We talk to the kids around town. The Sierra Nevada, is this still on? Sierra Nevada DreamChaser, the landing here at Huntsville. And we came up with a concept back in 2014, Teledyne Braun did, to land a DreamChaser at a commercial airport. And we had 2 different options, 2 different mission sets. We had an ISS return that made sense to leave the ISS, commercial resupply, to land at Huntsville. And then we looked at some sorties. So right now we've got 2 different orbit analysis that we're doing for this licensing. We've got one that's a return from ISS, and then we've got a Space Lab low inclination equatorial type orbit, so that if we go to a different mission set. We did the feasibility study back in 2015 when we made sure that we could land there. There's a skid plate on the front of the DreamChaser you might see. We were concerned about it possibly damaging an asphalt runway, since it wasn't intended for asphalt, it was for concrete. It's an Inconel skid plate. We brought a test article down, did the test, it passed. We had RSNH in town. They did work for us too. They did the environmental preliminary. It passed, so we were good to go. The next step was to secure the funding, and that took a little bit of time. It's a community thing. The Chamber of Commerce was heavily involved with us, working with the Huntsville mayor, the Madison mayor, the county commission, the state senators, the governor's office, the FAA, our senators, the airport, our leadership, Sierra Nevada. It was everybody involved, and we did secure the funding. It was about $1 million to do all this analysis to get this license submitted to the FAA. So we started last year, and then in 2019, we fully expect in December of 19 to submit a fully compliant license. The FAA reserves about 6 months to review it and send comments back. So we're on schedule for that. So why did we invest? Again, the diverse payloads and hardware that's on board the ISS today. That opened up our potential customers for this region, this area, from UAH to UAB, to Hudson Alpha, to Marshall Hardware from Eklist and Redstone Arsenal payloads. So it opened it up, just the diversity of the ISS. Another reason was the 35-year history again, plus of Teledyne doing payload ops and integration, and the strong commitment from the community. So risks and barriers for this project has been passing the feasibility and securing funding. We've done that. Now it's securing the mission. We've now got the U.S. Space and Rocket Center involved, offering help, and the newly formed Alabama Space Authority is offered support too to get missions to land here. So we've got Senator Dial involved with that process too. How do we improve commercialization? I mean, from this niche, I mean, it is a specific niche, but the FAA relationships, we've got to continue to grow those. It's something that, you know, we got introduced to. We hadn't worked with FAA before. They're new. They're getting a lot of commercial customers, a lot of spaceports and contact with them, and we're working lockstep with them, and we're developing that relationship. And I think for other airports to have this opportunity, I think they've got to do the same thing. When we do get this license, I will say that there will only be two places that DreamChaser can land in the world, and the other one will be KSC, and we're only 1 month behind in their development to get the licensing. So we're very close to them, and no one else has started. So I know there's a lot of talk of spaceports and what other airports are doing and all, but no, we're out ahead of it in the Huntsville area. The last thing, too, is to build on commercial competitions. The Chamber of Commerce has done a really good job of working with ESA and their Space Exploration Masters competition. It's the second year where they're identifying payloads that can meet this mission set for a mission to land at Huntsville with a DreamChaser type capability.
Thank you, Lee. Appreciate that. Again, start thinking about your questions. I almost about ready to ask a question just then, but I'm going to try to wait. So I said we're going to follow this format. So thank you very much for that. So our next presenter, next panel member is Mark Kinnersley, who has 25 years of aerospace management experience with the Airbus group in Europe and in the U.S. He is currently the Airbus resident liaison for the European service module located at the Lockheed Martin Space System in Denver. Mark, tell us more about your commercial ventures and what you guys are doing with Airbus.
Great, thank you very much. So I've worked for Airbus for, dare I say it, over a quarter of a century. Depending which country you're in, it could be Airbus if you're French, or Airbus if you're British or American. Just a few things. Airbus Human Space Activities in the USA. We're obviously a very large company, 130,000 people worldwide. The space part used to be called MBB Erno, then Astrium. We change the names every couple of years just to make sure we go through the business cards quickly. So I just want to say we do have an operational unit. We sit next door to Jeff's NanoRacks outfit. We work very well with NanoRacks. I put the US flag on because I'm also a recent US citizen as well. So I just want to say we are 100% US organization here, based in Houston. I'm based in Denver, work for that office. And we have a lot of heritage there. So we've been established here since 1973, actually, in Florida and in Texas, and now in Denver. So we've done a lot of shuttle stuff with payload carriers. I've been involved, obviously, with integrated cargo carriers, very commercial in terms of owning the platforms and then using them for shuttle flights, including payload integration. We've done a lot of work recently with cases. One of the interesting ones was the Sphere's tether demo, which was quite a lot of fun. And again, we're doing slosh modeling as well to help out with the propellant management devices on our propellant tanks. So we've done a lot of that. Commercialization, we've worked with Jeff on the NanoRacks external platform, on the design and development with our next door neighbors and integration operation. And of course, the STARS platform, where we developed the avionics. And I'll talk a bit about Bartolomeo. It's a bit of a mouthful. He's the younger brother of Christopher Columbus. That's basically the thing. And we'll get back into that in a minute. My day job is the Orion service module. We'll have it delivered in Kennedy Space Center, hopefully at the beginning of the month. So the teams are working hard at the moment in Germany on that. So industrialization and commercialization, yeah, we've done a lot of industrialization already in Europe. You know, we've operated the Columbus under an industrial operator team, so we're very used to that, and that's transferring responsibility to the private sector. So that's worked very well. And commercialization, what's the goal of that? I guess, you know, in every agency, whether ESA or NASA, the budgets are very flat. We want to make more efficient use of the budget and stuff like that. So commercial, certainly handing it over to private industry to, I would say, NASA being the landlord, and we're sort of developing the services on top of that. That's really the idea. And you'll get some very interesting ideas, innovative ideas, and I'll come back to some of them in a minute. But I think essentially increasing the efficiency. If I take a point out of my previous life in commercial launch services, I remember as a young lad, if you wanted to launch a satellite on the launch vehicle, it would take 3 years integration time or something like that. Ariane Space pioneered that. We got down that, and the industry standard is 12 months. So it's a sort of parallel to what we want to do with payloads, essentially, is have a very quick turnaround time. So we've seen this before, but there's a lot of potential. We want to get new actors involved outside of the space sector. And I think our motivation as well is, I mean, there's more risk, but there's potential for more profit as well. So I'll go very quickly through. So we want to do pathfinder cases to test the market. So as I said, real estate development with Bartolomeo. Bartolomeo is not an ESA platform, NASA platform. I mean, a lot of support from both, but it's privately funded by Airbus. So we want to work with both entities and other customers essentially to do that. And I'll come back to that in a minute. It's a great platform. We're also building a thing called ACLS, Advanced Closed Loop Life Support System. It's just been launched. It's going to be commissioned soon, where we're producing breathable oxygen via electrolysis. Once we get that going, we actually want to have a system in place where we sell the services, basically breathing air to the station, essentially. So that'd be quite good. So as a service, so we produce oxygen, and hopefully that's the model we want to go down. We want to foster utilization demand because I think if we can make this attractive, lower barriers to entry, I think this will be excellent, and we'll get, I think it'll snowball. And as I increase, affordability, there's a lot of innovation out there. It's an exciting time at the moment with all these different actors coming in. So that's the key. So you can see on the right-hand side there now, facility in Friedrichshafen, the ACLS, which should be commissioned next month. Again, Bartolomeo is an all-in-one mission service, very highly competitive rates. I don't have them in the top of my head, but certainly very, very attractive. You don't need to design the platform, the bus. We want to try and aim to 12 months integration time. You can see there on the right-hand side of that picture at the top, we've got viewing in 3 directions, nadir, zenith, and RAM, and we can cope with all sorts of payloads. And of course, we want to have the right platform for the right, applications. So there's a few platforms around, so we'll all be fine. And we're it's exciting times at the moment, and we'll get this stuff put through the airlock and placed in there by a robotic arm. So as I say, highly cost-effective. We're using, a Gold 2 interface there, which is very highly cost-effective as well. And we have I think we probably have one of the highest data rates there, downlinks. We're very excited about it. We should be ready to operate early 2020, and we've got some serious customers getting prepared for that. So just some remaining thoughts. So what's the motivation? We've been doing traditional business a lot, but I would say that in Airbus Europe, we've been used to firm fixed price. ATV was firm fixed price, for instance. Orion service modules, firm fixed price. So we need to increase the potential market size. We've got to look at other markets, and if we can streamline this and make it more attractive, we can get more business because the budgets are flat in different parts of the world. So I say stress is really services. We've pioneered that with communication satellites, Milcom sats as well, and be very, very flexible and pragmatic. Of course, we will take on more risk. We're investing our own money, but because of that, I think we can accept some potential risk to fail. Obviously not affecting safety, but we want to take more risks in terms of that so that we can have a less complex system and drive down the cost of the missions. Democratize space access so that everybody has an opportunity. And as I said, last but not least, I don't want to bring more regulation into this. We want to commercialize, but on the other hand, we want to try and align common interfaces and standards. I know this is an issue with Orion, with European standards and US. But that's about it. Thank you very much.
Thank you, Mark. Very insightful. So again, a lot of great questions. I think that's going to come from that as well. Now we'll move on to our third panelist. I will say I had the pleasure of talking to Jeff just a couple of weeks ago when we were at the IAC. But from a formal introduction, of course, Jeff Manber is the CEO of NanoRacks, whose company became the first commercial space station company with customers. NanoRacks has launched over 700 payloads. Today, Jeff is focused on owning and operating private space stations called outposts in low Earth orbit. And with that, Jeff, tell us more about, maybe talk a little bit more about scalability and what you see from a commercialization perspective, and share all your information with us.
I'd like to do that. One of the before I, then the challenge from the moderator, before I begin, one of the challenges we all face on commercialization on the ISS, I mean, to everybody in this room and to all in the industry, I mean, how cool is it that we work on the space station? To the financial community, it's like having a good franchise on the Titanic. I mean, it has a set lifetime, and it is extremely difficult. That may be the captain calling. It's extreme. Yeah, it's extremely difficult to envision, especially for a company like NanoRacks, which is focused on space station for most of our revenue, to try and figure out how to scale beyond that. I mean, you say all the logical things. You say 2024 or 2028 is a long time away. Okay, I mean, we wish every program had the guarantee and the stability that we have in this industry with station. But for the financial community, you must show that scalability, and I'll touch on it, the outpost moving beyond ISS is the scalability that we're looking for, but it's really jumping ahead, but you challenged me to do that, so, okay. So NanoRacks was the first company to own and operate its own hardware on the space station. We started 9 years ago, and we went to NASA and said, we don't want your funding, which got NASA's interest. And to date, in a variety of hardware, we've invested over $40 million. And we're a small company. We're 9 years old. We're about 60 people. And the hardware starts with the Nano Lab, small standardized, talk about standardization, laboratories that go into a powered platform. And just as an aside, I'll say I personally made the decision 9 years ago not to patent the Nano Lab. And I remember Jason Grzan was so happy at headquarters, and we made that decision because I wanted an ecosystem. And as you're hearing today, I mean, all of us, in one sense, we're competitors, in another sense, we're not, and in another sense, we're in this together. And we need that interoperability. We need an ecosystem. So today on the Nano Labs, NanoRacks is competition from a couple of companies, domestically and in Europe, and we're hopeful that helps the market to grow. And as you've heard, we have customers. We have customers in 32 nations now. And that's pretty awesome for a small company, and it's really been extraordinary help from NASA, the program office, headquarters. One of the first customers we had from a non-ISS partner nation was University of Hanoi, and we were very fortunate that not only did NASA support that, but all the ISS partners had to vote to approve a payload. And that was our first one, and after that, we're sort of off to the races. And so now as I said, we've had 32 countries that have been represented. Let me say something. I've been in Washington for a while now, and being stubborn, I've had one of the same arguments for the past 20-something years that I've been in Washington. You can be commercial, and you can have a commercial customer, and that commercial customer can be a government organization. There's a big debate in Washington. ESA to us is a customer, and they're commercial. NASA is a customer at times to us, and thank you for all that. It's commercial. It's our hardware. We invested in it. If we don't produce, we don't get paid. That's commercial. Just like when Mike flew here today from Houston, he flew, as a commercial customer. He didn't design the plane. He didn't develop the plane. They probably get better prices than when we fly because they're bulk. No, I mean, just to go through the market. But it's still a commercial customer. So sometimes people say, you're being hypocritical. You got ESA and NASA. But a lot of times that's as a commercial customer. And that's changing the public-private partnership that we'll talk about right now. So, I mean, one of the most fascinating things for me at NASA now for 9 years has been the changing public-private partnership between us and the program office and NASA. When we started off, neither side kind of knew what we were talking about. Well, I'll speak for myself. I didn't really know what we were talking about in terms of public-private partnerships. What do we have to invest? And over time, first with our nanolabs, and then our satellite deployment system. We've deployed over 200 satellites from the space station. We paid for the deployers. We had the concept. We developed the market, but we couldn't do it without using the NASA agreements with JAXA. And so there was a growing public-private partnership there. Then we've come up with the idea of the Bishop airlock. Why are we doing an airlock when we have the Japanese airlock? I mean, why is the private sector willing to commit funds to do an airlock when one exists now? It's an investment in the station. Our airlock will be 5 times bigger than the Japanese airlock. We hope it will be run more efficiently. No offense to our dear friends at JAXA, because it's the commercial sector. And it'll be more in tune for the way we see the market developing. And then finally, as Bobby mentioned, we're looking at developing private space platforms, plural, using repurposed upper stages of the Atlas V. We're working with our good friends at Boeing down here in Decatur with ULA, with Maxar and SSL, Mike Gold, who you'll hear from later in the next panel. And there, the public-private partnership has to be far more mature. What does the private sector contribute? What does the NASA contribute? We've been aware from the beginning that we're on a government-funded platform, the ISS. And from the beginning, I've really been clear that we have to give back as much as we can. And sometimes Mike and I reached agreements that we would provide services to NASA for what we were developing, and NASA was contributing the resources. So there's no one single answer. I will say to your question before as to why did we invest, where do we see the market? On a macro sense, I see the macro change as government as customer. And we're developing commercial marketplace in the States, which is a wonderful thing, where space is becoming a legitimate marketplace in crewed space, in space stations, in satellite deployment, just as it's been for satellite communications for some time now. This is, I think, if I press, this is a video. Nope. Okay, it wasn't a video of it. I guess, and I thought there was a slide that said, or maybe you can't read it. I'll say one of the concerns, one of the challenges, Bobby asked us to look at the challenges, and one of the challenges that we face, we're concerned about at NanoRacks, is we've made this investment of, in this case, some $40 million into the station, and you've heard from Teledyne, Braun, and Airbus that they've made contributions and investments as well. Well, how do you lock that in, the upmass? How do you lock in the station resources? How, under the present situation, can we ensure that our investments will allow us to have access to our own hardware in the years to come? And right now, all of us are grappling at NASA and the private sector. What is the policy? What is the policy for access? What is the policy to use the space station in the future? How do you treat folks differently who may have no hardware on the station? And I would argue you should treat folks differently, who may have maybe a small piece of hardware on the station, to those on this panel who have major multi-million-dollar investments. And that's one of the things that we're grappling to solve the problem. And the administrator has appointed Mr. Gold here, over on the left. Bring to him your problems. And he's going to be, he'll be working over the next few months to try and figure out, among other things, how do we ensure that those who are making the private sector investments today have access in a way that makes sense to the station in the future? And I guess that's it. Fat chance.
All right, thank you, Jeff. That was very informative as well. Okay, so you heard from industry, some of our industry partners. Next, I want to turn it over to Mike Reed. Mike and I had a chance to do a similar type discussion. I think it was last year, maybe more on utilization and payload operations. But Mike is out of NASA Johnson Space Center. He's the manager for the commercial space utilization for the ISS program. And Mike, I think you are the right person to really kind of help solidify and kind of talk about what is the right approach for commercialization? Or even before that, what is commercialization? and how are all these pieces coming together, and how you're going to define all that, and how we're going to move together as a government partner with industry, et cetera.
So what you're really asking is, why are these guys and their companies all crazy enough to put money into space? And why is that important to us? So that's probably where I ought to start, which is really the end. I want to go tell you what our goal is, and then I'll come back and tell you what we've done and why. So the goal, while we've got ISS, is to use its assets, its resources, to help companies like these and others develop a vibrant, robust economy in low Earth orbit. Because when ISS is gone, they're still going to need a platform. We certainly are still going to need a platform. So the end game is, as it's been mentioned here, is government as a customer, just not the only customer. That's just not sustainable anymore. So all of these guys and their companies and their investments are players in this bigger picture of trying to enable an economy in LEO. And I say enable because we're the government. We may try to help, but we generally end up not really helping. We can't create. The private sector has to create. We can kill something, but we can, better yet, try to set the environment whereby guys like this and companies can see opportunities and exploit that, especially leveraging the ISS while we have it, but then ultimately to carry that on afterwards. So why do we care? We put out a transition report last spring, and one of the key takeaways, if anybody looked at that, was clear, is that NASA is always going to have a need for a platform in LEO. We're going to do fundamental, decadal-driven research. We're going to do applied research. We'll probably be doing national lab research, which is other government agencies, commercial sector, whatnot. We'll also be training our astronauts. We're not going to fly crews to deep space. It's almost a certainty on their first mission. We're going to do crew proficiency in low Earth orbit. We'll do crew training. But more importantly, we're going to test out next generation systems, because fluids and things like that just don't work the same in microgravity that they do in 1G. And I just don't see us sending advanced systems to deep space before they've been proven in microgravity. So NASA's always going to have a need. And so it's important to us. Well, okay, the other takeaway is, and it's pretty clear, but I'm going to say it anyway, is that ISS is almost certainly the last government-driven platform in LEO. It's not going to be another one. The budgets don't support it. So having said the first one, which is we're always going to have a need, and knowing the second one, which is ISS is going to be the last government, that means there has to be a commercially led, commercially driven platform. Government can be a customer, but it has to be a commercial platform there so that we can use it. But more importantly, we need other customers to use it as well, because if we're the only store in the mall, we pay all the overhead of that mall, and that's not sustainable. That's like buying another ISS, and that's not going to happen. So what have we done? What has been our approach? A lot of it you've heard right here. We've enabled these, we call them commercial service providers, because they own their own hardware. And they're marketing it, which is important because it's going to customer bases that's beyond selling to the government. Bobby asked, what's commercialization? Commercialization to us is setting our requirements, not design solutions, but setting our requirements, and then let the commercial sector provide the solutions, provide the services, and sell services to us, but we're not going to be able to close their business case. Jeff will tell you right off the bat that we're not the majority of his customer base, and that's good. We want to see that diversification of use of the ISS, because that drives the next platform. And so we've got about 8 or 10 companies now that we have got contracts with that are either operating their own hardware on ISS or in development to do so, which is good, and it's across a diverse facility base. They're new capability for us. They filled gaps in our capabilities that were originally designed 20 years ago. So it was important to upgrade, and we did that not buying hardware. We did that buying services. So we've got a number of companies that are operating or will be operating on ISS. But the demand still requires a lot of subsidy. CASIS has done a lot of work over 6 or 7 years going to the non-traditional users, having to educate them, And then in many cases, we still provide the implementation partner cost that translates their investigations into a microgravity investigation. NASA pays those costs because we want them to see the benefit of doing it, so ultimately they will pick up the cost. And they're not even coming close to paying for the subsidies of upmass, of crew time, onboard accommodations, power data, all of that. So it became clear to us this past year that we've got to change our focus a little bit. We've got a lot of good facilities on board now, but we haven't done enough to do direct, sustainable, scalable demand stimulation. And so we started looking at what our options were, and our SBIRO program is very robust, and we use it very heavily in the ISS program. We take a lot of things that are developed under the first phases of that program, and then we take them to flight. And that's good for the SBIRO program, it's good for the small companies. What we need is a scalable demand, and that probably means in-space manufacturing. And that can be exotic fibers, it can be cell line manufacturing for research, it can be bioprinting, tissue growth, a number of things and things we probably don't even know of. So we started pivoting to take a little bit of money we put together to help a handful of these come out of the SBIR program and get to a flight demonstration. And if any of those are successful, it's the rising tide that will lift all boats. It will provide a shared overhead for these guys to continue on the next gen platform. It'll make NASA not be the only customer. So economy has two sides to it, right? We've got the supply, and we're pivoting now to work on the demand. So, Bobby, I think I'll leave it right there.
Sounds very good. Again, thank the panel for what you guys are doing in discussions. And now I'd like to open it up to the audience for questions and comments. I know you guys have been thinking about your questions, so I want to kind of reach out and get some of the questions we have from the audience.
Somebody besides Frank.
All right, should have known this one was coming. Frank Slazer with the Aerospace Industries Association. Just question, obviously there's an initiative this year by the administration to say we're going to stop doing ISS beyond 2025 as a government enterprise. Do you believe that it's possible for the station to be a commercially supported enterprise by that time, principally commercially supported enterprise by that time? And if not, when do you think it could be? Or do you think it can be?
Well, I got the nod from Bobby, so I guess I get to field that one. Space Station was set up as a government program. It was set up to be viable politically. It was set up to be viable internationally. It was not set up to be run efficiently for a profit. Are there elements of it that could be spun off and operated commercially that make sense? Probably. We would have to go through probably another round of announcements to go see if there was interest in even doing that. But taking what was a government program and turning it into a profitable corporate venture is probably not likely. We looked at doing that with the shuttle in the mid-90s. It was equally non-viable for very similar reasons.
Yeah, Frank, if I can just sort of push back just a little bit, I think what the administration announced was at 2024, 2025, seeking to change the relationship between industry and the government in terms of NASA. I don't believe they announced that we're going to end the space station or, you know, it was more, let's look at changing the relationship. Maybe, and I'm speaking here for others, but maybe the government pays the cargo ships directly, or maybe they're just changing the relationship rather than having NASA being the sole procurement, for lack of a better. So I was actually fairly encouraged. I mean, now there's been this whole political thing. No, we're going to keep the station to 2028. You know, fine. I mean, that's wonderful. I've never been one to see us deorbit and waste hardware that's in space. That's precious enough. But what excited me about what the Space Council announced was they were saying 4, 5, 6 years ahead of time, let's look at changing the relationship, what works. So that actually was, I found to be interesting and refreshing.
Very good. Questions? More questions?
Yeah, this question is for Mike, but I have a feeling several of you are going to want to pitch in your thoughts on this. So, Mike, you were saying that the ISS is going to be the last government-funded platform in low Earth orbit, and yet we're always going to need a platform in low Earth orbit. You know, part of what has made commercial opportunities on ISS attractive is that so much of the infrastructure is already there. Jeff didn't have to fund the assembly and fabrication of the ISS from scratch. He was able to jump into a facility that's already there. So when you think about a commercial platform in LEO, how are you going to get a commercial enterprise to pay those from scratch costs that will make it possible for them to have something that we could buy as customer?
Well, I think we've shown how to do it with the commercial cargo and the commercial crew programs. You know, we had several phases of those where we got more comfortable with their design solutions, their integration processes, and there was drops of money to help them during the development. It wasn't that they had to fund it from scratch. And then we ultimately signed service contracts with them to use the vehicles for crew or cargo transportation. So I could see something like that, modified however it needed to be to fit a platform. But there's no question about it. The government is going to be, at least initially, the largest customer. We're not going to do it if we believe that we're going to be the only customer. I mean, I just don't see that being sustainable financially. But I can see us being that early adopter where we put money in, because that's what the government does. We do things that are inherently governmental that the private sector just can't step up to do. So I think there's things that we've done that probably lend themselves to being adapted for a next-gen platform.
Very good. We got one more question here while he's making his way over. Mark, I would like to pull on you for a second also while we get this next question queued up. You talked about a 12-month turnaround for customers. Is that like a high water mark, a low water mark? Is it going to get better than that? Because I think that's going to be key for commercialization too, right? Turnaround time?
Yeah, definitely. Turnaround time is vital. It's not just in this industry, but in other ones as well, especially people doing research and PhDs. You want to have a very quick turnaround time. So I think that's a target at the moment. I'd say we're probably likely 18 to 12 months, something like that. But we think it's certainly possible. And I just want to say a bit about, what Mike was talking about. I think we need the government as an anchor tenant, essentially, for a lot of these services, not getting out completely. It's a similar model we've had in, say, our Paradigm commercial satellites, where we sell the capacity to Ministry of Defense or whatever, and then we can use that spare capacity elsewhere to bring new business. Okay, thanks.
I'll just add too, that's where our line is. If we can get under 12 months, we feel like there's a lot more capabilities and opportunities to get payloads up there. I mean, we're 18 to 24, but that is the line.
Right, so not in any rush to get rid of the space station, but since the topic was broached of what comes next, we've already found that we can make smaller satellites. We don't need the larger ones anymore. So barring the human factors concerns of how big the space station should be, whatever comes next, should it be something smaller than the International Space Station, or maybe we should even have multiple smaller stations?
As Mike said, a great question. As Mike said, this ISS was designed by governments for governments. You'll never have a space station in LEO again like the ISS, nor should there be. Having the modules attached together doesn't make sense when you have some markets that will be for, robotic and some are for human. We know we never want that again, but it was politically made sense. And also you touched at the end on the perfect point. We are doomed if there's one commercial platform that follows ISS. The paradox is we need 6, 8, 10. Why? 1, you need an ecosystem. 2, you need to attack different niches. 3, you need to be in different orbits and inclinations. So at NanoRacks, we may be interested in, permit me to call it unmanned platform to do in-space manufacturing, and maybe Airbus or Teledyne Braun or Bigelow or Boeing in the future want to have a space hotel. Well, you don't want to attach those together, but you want to use the ecosystem we've developed in partnership with NASA and the cargo and develop a new ecosystem on return vehicles. It doesn't make sense for one platform, and you don't want a whole bunch jumbled together. You want an ecosystem.
Alan, we have one here.
Okay. Ron Burke with the Aerospace Corporation. Thank you, Jeff. Following up on the point about ecosystems, it would be valuable to hear from the panel what the top 5 or so major components or elements that you see as being necessary to have a robust ecosystem that is sustainable.
Thanks, Ron. It's like the 10 most on late night television, right? Okay, so well, for number one, I mean, for us to have an ecosystem that we're looking at, you need all the components. And I don't know if I can do 5 right now, but first off, we really need a return vehicle. We need something smaller. I mean, Dragon is fantastic, but we really need something smaller, automated to return, and even small in DreamChaser. I mean, DreamChaser is great. That's good. It's wonderful. But actually, I mean, as you look out at different platforms and different orbits, you need some small, very low cost return vehicles. That's really critical for the ecosystem to develop. You need, as Mark said, standardized hardware. You need the ability, like on our Bishop airlock, we have some common interfaces with your platform. That's not a coincidence. Will we work together? Let's hope so. But we've designed the ability to have the interoperability to work together. Another part of the ecosystem is government as customer. I don't know if that's, again, not anchor tenant for us, but government as customer. And then also you get into things like insurance, risk mitigation, greater sophistication of the private sector to provide the liquidity. Also, end some of the protectionism that exists in our industry. I'd like to bid on a JAXA program. And why can't Japanese companies in the right sense bid on a NASA program? This is one of the last great protectionist markets that exists. And how can we work together to allow the private sector to begin to bid and work with the different foreign space agencies? So for us, an ecosystem is not just hardware. It's capital, sophisticated capital, risk mitigation, and different components of one other thing is that to allow the IGA, let me just put, part of the ecosystem is to allow the Intergovernmental Agency Agreement, which is the rules of conduct on the station, to continue and to grow and to include the commercial platforms. It's been a very important part of how we can all do business. It waives third-party liability and a whole bunch of other nifty good stuff.
Go ahead.
It's getting more difficult to have ideas after all those, but I would agree download of small payloads is an excellent idea. I would tend to agree with that. In fact, I'll dig out an old study we did 10 years ago and revive it. The other thing, I think the IGA is very important. It's also the basis for our cooperation on Orion, and it took a lot of work to do. So, yeah. You're using it on Orion? Yeah, it's a subset of that, basically. So it's, yeah.
All right, very good. While we're queuing up the next question, I was thinking on the DreamChaser. Lee, was there any interesting or out of ordinary type questions you guys received or had concerning with that capability you discussed?
Yeah, so it was very interesting starting this whole concept, and you know, everybody that's involved, I think I listed probably 20 different entities, but air traffic control, we had to talk to the different airports. So we went from Memphis to Birmingham to Nashville to Atlanta. So Atlanta air traffic control had a concern. They wanted to know, just to be clear, how many DreamChaser landings there would be each day.
Very good.
Yeah.
So what's the answer?
So it was, multiple we hope for, but if we got one a year, we would be very happy.
All right. Hey, guys, I really appreciate that. Again, to get ready for these panel discussions, the panel members, they put in a lot of prep time, pull together information. We spend time talking as a committee to try to organize what's the best way to present that information to you. So with that, can you give these panel members a warm applause for the all hard work that they did? So really appreciate them. Really, really appreciate them.